Oh hey, what's happening there YouTube? It's Brian House here for Housemade, and today in the studio we are going to be building the Evolution belt grinder. This video is just a build video. I've created another video that shows off all the features and functionality. Many of you are probably asking yourselves, why did you decide to evolve away from the Revolution? And the biggest, most important reason is this machine is so much quicker and easier to build. It does not compromise on any of the rigidity, the functionality, or any of the features that the Revolution has. In fact, we've added to it. In today's video, we are just going to be building this. So if you bought a kit from our website, housemade.us, make sure you watch this video all the way through so you can achieve a top quality build right in your workshop. Anyway, guys, let's get started. Let's talk a little bit about the tools you're going to need to make this happen. One of the things most people don't think about when they go to build any machine is the amount of tooling they're going to need and what that tooling costs, right? So the Evolution was designed to be built with simple tools. You're going to need some clamps, box end wrenches, ratchet set, some Loctite 242. You're also going to need an angle grinder of some sort. This is a pneumatic one. You can use an electric one, and a flap disc is handy to have. A 1, 2, 3 block or a machinist square is also very useful because we are going to use these to check for square. All right, so for this project, you're going to need a welder, and I am still rocking the Hobart Handler 190. This is the first welder that I ever purchased. I built my first 2x72 belt grinder with it. It is a fantastic machine. I'm super happy with it. All I've ever had to do is replace the torch. The old one just wore out over time. I'm going to put a link down in the description so you can find one for yourself. In this case, because the steel is so thick, I'm running a voltage level of 6, and my wire speed is set to a 6.5, and we are running a 75-25 argon CO2 mix so that we get those nice clean flat welds. Okay, so the base assembly consists of 4 plate steel parts. That's the base plate, the 2 risers, and the center gusset, okay, that goes in between. This is kind of cool because you get to customize the plate that goes over this to your particular business or whatever you'd like it to say. And also at this time you're going to want to grab your big bolt and the nylock that goes with that bolt, okay? We're going to assemble this kind of a weird way, but just bear with me here. Now, the risers are different, right? So the HM, this should say H and M, okay, in the front. So this is how the orientation should look if you're standing at the machine. This slanted portion of the riser should be to your right, okay? So I'm going to take this, set this on the table, take my center gusset, click it into the rear riser, put this on top like this, lay the whole thing down on the 2 flat surfaces, okay? Get 2 flat backs here like this, okay? And then I'm going to take one of my clamps and I'm going to align it with the tabs that are a part of the center gusset, and we're going to clamp it into position. Next, we're going to grab our axle bolt and slide it through both of the holes, just like that, and loosely thread on the nylock, just to kind of keep it in place. Doesn't have to be tight at all. And then we're going to turn the entire assembly and slide it over to the edge of the table, align our base plate with the tabs that are on the bottom of the risers, and we're going to clamp that into place. So take a couple of your big clamps and open them all the way up and position them just like this over the top of the riser and the bottom of the base plate, just to kind of snug it all up. I'm going to do this on the other side as well. So now that we have it clamped both this direction and this direction, we're going to grab our 1, 2, 3 block again and just double check for square. Everything looks good, so let's get set up to start welding. All of the tab and slot construction on this grinder looks a little bit like this. This is what I call a duck mouth tab and slot, where you've got a little groove down in there, and that's where the arc should start, is at the bottom of that little V section of the tab. And then you're going to build up that weld until it starts to adhere to the other pieces of plate steel. Essentially all the welds on this machine are tack welds or plug welds, whatever you want to call it. But we did that by design so that all the welds were somewhat hidden and could be ground back to smooth if necessary. One thing to be mindful of when you do this is you do not want the weld to be proud of this flat surface, otherwise your grinder won't sit flat. However, if you do go over and it is proud, you can grind it back with ease. All right, so this is what we're looking for here. Nice filled in low portion that blends over to the other plate steel. Before I flip the grinder base over, I'm just gonna run a 1, 2, 3 block across my welds just to check them, make sure nothing's sitting proud. If anything's sitting proud, then I'm just gonna hit it with a flap disc just to make it smooth. So now that we have the base assembly all welded together, we're gonna pull this nylock off and slide the bolt out. We're gonna tip the whole assembly on its side and finish the gusset welds both forward and back. So now you're gonna take these two funky looking pieces. This is your spring tab. This is gonna hold the bottom of the spring, and this is the gusset that adds rigidity to the grinder body. And we need to marry these two pieces together, okay? So you're gonna take the gusset, you're gonna set it down on your flat work surface, slide the 1, 2, 3 block up next to it, and rest the tab down into this slot, and rest the end of the tab on the 1, 2, 3 block. This doesn't have to be a 1, 2, 3 block. You can do it with just about anything. I like 1, 2, 3 block just because, you know, we're using it already. And then you're gonna put distance between the end of the gusset and the 1, 2, 3 block. It needs to be about 3/4 of an inch to get us to the 120-degree difference that we need between these two parts. Now, when you go to weld this together, the cooling of that weld, when you splash that weld down in there, it's gonna wanna move that spring tab that way, right? It's gonna wanna cool and pull it that way. So you're gonna wanna put your hand down on this and just lightly put some pressure on it so that it doesn't actually move. Now, if it does move, tack welds are your friend. Remember that? You're just gonna wanna tack weld it. Check it to make sure you have the right degree. If it does move, then you can just take a hammer and tap it back into place. Then we're gonna flip the part over and finish the weld on the backside and grind it smooth. All right, so now we're gonna start building the grinder body itself. We are going to start with this big side plate here, the 2 hinges, the spring tab body gusset that we welded up just a few minutes ago, the big bolt, and from your hardware pack, you're gonna wanna grab these 2 very thin shims, okay? All right, so let's go ahead and grab our big bolt, take the nylock off of it, and we are going to slide on, right, the first hinge here, okay? And orientation matters in this case. It's gonna be sitting like this on the grinder. This bolt is gonna go through the front of it, just like that, right? So you got it set up like that. You're gonna grab 1 shim, slide it down. It's just gonna isolate the hinge from the base assembly. Slide it on across. It's going to go all the way through. You're going to take the second shim, slide it over the bolt, and align this non-slotted hinge in the back, just like this. Okay? Grab your nylock and you can just loosely tighten that up while you double check your orientation here. Orientation is the slotted hinge goes with the HM logo in the front. You can see there's also a drilled and tapped hole in this plate. That is for the pivoting mechanism, okay? And the tabs of each hinge should be facing where this angled portion of this riser is, okay? Now we're gonna go ahead and tighten up this nylock so that these hinges are just slightly captive. I like it tight enough just so I can turn them, but they will not fall if, you know, they're left to their own devices. You just want it to be nice and snug, but you should still be able to turn it. So now we need to weld in the body gusset and spring tab assembly, and we need to weld it to this side plate right here. And this can get confusing. These two plates can only be oriented in one way. So what we've done is we've made it super simple. We have laser etched the word inside on both of these plates, okay? So if you can imagine, this is the inside and this is the inside, and they sit like this, okay? So we're going to take all three of our center plates and we're going to place them into the motor plate as they go. And then the body gusset and spring tab assembly, and place that where it needs to go. And then we're going to rest the side plate with the word inside on it on the inside, right? So we're going to take, there's the inside, we're going to take it, flip it 180, and set it all down in, let it click into place, okay? And I can't stress this enough. We're not going to be welding anything on this side at all. We are only simply going to weld this side of this side plate right here, the body gusset and spring tab assembly, these two welds, okay? And you can take a green marker or whatever you need to do, circle that, and only weld these two welds into place, because this whole thing has to come back apart so we can finish the other welds. There's certain spots on this that require welding from down on the inside to hide the welds, okay? So forget about this side. I know it's tempting. I know you're going to go, Brian, it's laying right there. It's like so easy. I could just do it right now. Don't do it. Just don't do it. It's going to create a whole bunch more work for you later down the road. Just these two right here. We're going to weld that body gusset spring tab onto the side plate, and then we're going to take it all apart and start the assembly of the hinges and the side plate on the grinder itself. Okay, so now that we have the body gusset welded into place, we are going to lift this off of the assembly and we're going to transfer it over to the grinder. Now remember, orientation matters in this case. So we're going to set it down on the hinges here. Click it into place. You can see the body gusset up here is facing up, and the forward portion of the grinder looks like this. Set up like that. So this flatter face here is aligned with the HM logo, okay? Then we're going to clamp this down into place by using the base gusset all the way up to the top, clamp it into place, and then weld the hinges onto the side plate. So now we're just going to check to make sure that none of these welds are proud. This is really important, okay? I got a little bit of weld right there that needs to be ground back. A little bit over here. So we're gonna hit it with a flap disc and just ensure that there is nothing sitting proud on these welds. Remember, there's going to be tooling arms that go in here, and anything that impedes those tooling arms from moving is going to be a problem. So let's get it done. Nice and smooth. All right. Okay, so let's just take an inventory, quick inventory of where we're at on the build. We've got the base assembly all welded up. We've got our hinges bolted on. We've got the side plate welded to the hinges. We've made sure there's nothing impeding anything here. We're nice and smooth. Check that with our 1, 2, 3 block. And we've got our body gusset with our spring tab welded onto that plate, only on one side. We are going to grab the three plates, the three center plates. There's two of which that have holes drilled and tapped in them. The holes go towards the logo on the front of the grinder, and they go on the top and the bottom. And then the plate without the hole goes right in the middle, okay? And we're going to grab our tooling arms. One of the tooling arms has holes in it, okay? And that's your Platen arm. We're going to set that right on the top. That's the Platen arm there. And then the other one is just a straight bar, okay? And that gets put in the bottom just like that. This is for the work rest. We'll assemble that later. And then we're going to grab our motor plate, and this is the fun part where it all kind of clicks together. Set that down on top. Looks good. Oh man, it's coming together. Now for this operation, we are going to need 3 clamps, and they go on specific ways, okay? So we've got this all planned out for you, so follow along. The first clamp is going to go right on the top, right where the body gusset and spring tab are, right in between those two welding points, okay? So we're going to clamp that one down first. And the other 2 clamps are going to go right behind the center plates. And again, we're not going to clamp these down super tight. but just enough to snug them down because we need to adjust the tooling arms and make sure that those will slide in and out with ease. So it's important that we don't start welding until we figure that out. So now we've got the 2 clamps right behind the center plate. We've got one up here by the body gusset. And what we're really looking to do is ensure that these tooling arms are sliding without any problems. And you can see this one is a little tight, okay? And the reason why we're placing the clamps in these particular locations is because we can then loosen them to give ourselves a little bit more freedom when these arms are in and out, okay? So we're just looking to apply pressure, but then we also want to make sure that these arms slide in and out. So right now the Platen arm is in a good spot, and I think it's okay as far as the play in the receiver. This one though is getting stuck a little bit, so we want to kind of adjust the pressure or the location of these just to kind of get us to a point where this thing can slide. So if I've got this clamp all the way loose, it still has a little bit of an issue, so we know it's not that clamp, it's probably this one. I'm just going to loosen this one a little further, and that gave us the play that we needed. So because, you know, everything on there is just resting on these center plates, so this is kind of a little bit of a fiddly process, but you do not want to rush this, okay? Because every single tooling arm you slide in and out of this, you'll be asking yourself, why didn't I take more time when I did that? Because when I try to slide something in there, you know, it's a tight tolerance. And the reason is we don't want a ton of play in here, we just need enough for these to be able to move properly in and out. Okay, so now that we've played around with this thing, we have ensured that we have the right amount of play in both arms. Everything slides in and out. And there is a very specific welding pattern that we're going to do for all of these different welds, okay? So we're going to do on the upper and lower, right in the center, and then we're going to go in an X pattern, okay? And the reason why we're going to do that is because steel warps when you weld it. In this case, you're going to want to check after each weld. Is everything still moving in and out? Okay. And when I say each weld, I mean each weld. So do your tack weld, your plug weld, and then on each one of these, and then go ahead and check it, and then start your X pattern to finish all the welds off. Now that we've got all those forward welds done, we're going to go ahead and weld up these 2 welds that support the body gusset. Now we're going to go ahead and grind all these welds flat because later in the build we are going to put on our Evolution nameplate. So we want that nice and smooth. Okay, so now we've got our welds all ground down flat. Check this out, looks pretty awesome. We do have to deal with the welds here on the back side, okay? And you've got the same amount of welds that you have on the front side. However, there's a couple of caveats here. The ones that are closest to the hinges in the center, we just do the center weld on that. We don't actually weld close to the risers or the hinges, and that's because if you mess that weld up, now you might be a great welder and you could get it done, but if you mess that weld up, it could impede the hinging mechanism here, so just keep that in mind. If you go a little proud over there, you could run into an issue. You'd have to take the grinder apart. Now, if you're going to take the grinder apart and flatten those welds anyway because you're powder coating or you're painting or whatever, then it's not a big deal. You can do it there. But in this case, we're going to leave this grinder raw for now, so I'm going to go ahead and put those welds in right now as the grinder sits. That way I don't have to take it apart and fiddle around with putting it all back together. But I'm going to go ahead and lay those same welds on this side. We're going to get it done. All right, so now we're going to move on to the tracking mechanism. This is what we call a fast track system. You're going to want to gather your hardware and your parts. There's a little bit of fabrication that has to happen for this. We've made it easier to build on the Evolution. So the first and foremost, the big part, which is this guy here, this is your tracking arm, okay? And orientation matters in all of this, so you're really going to want to pay attention to this. And then you've got tracking handle, again. Orientation matters with this guy, so you're going to want to follow along and ensure, look at the instructions with the drawings and everything before you weld this stuff on. You've got the tracking mechanism, you've got the bolt knob parts and the Hinge joint and the secondary tracking knob and a couple other little pieces of hardware. This is all laid out for you in the instructions, so you don't have to memorize all this for right now. The first step is going to be to take this tracking arm, and what I like to do is I like to grind a chamfer right along this edge, and what that's going to do is that's going to give us a spot so that when we go to weld on the tracking handle, there is good penetration right in that location. So that chamfer needs to be put there before you weld this on. Before I go too much further, because this arm is a little funky looking, the angled portion of it, this is in the back, okay? So this goes in the back. That's not where the chamfer goes. The chamfer goes on the bottom front, right here. And to orient yourself, you can find this drilled and tapped hole in the very top of the arm, forward portion of the arm, in the very top. You're going to want to rotate it 180 degrees and chamfer this edge right here. All right, so we got our chamfer on there. It's a little wonky. It doesn't have to be perfect. Remember, we're just giving ourselves some space for the weld to fill in there. So that looks pretty good. About 3/16 to 1/4 inch down towards the center of the tube there. And the tracking handle, again, orientation matters here. When you're looking at it there, you should see that the handle is off to your left, okay? And that's important because none of this will work if you weld this on incorrectly. So the easiest way I've found to do this is to lay the handle down flat on your work surface in the correct orientation. Remember that, look at the drawings. Don't just look at this video because it can get a little confusing. And then put the tracking arm down right on top and kind of align it left to right and just make sure everything is flush. Now you can kind of clearly see the reason for that chamfer there, right? That's where our weld is going to sit, okay? So we're going to go ahead and put some pressure on the top of the tracking arm while we weld this down. There's really no easy way to clamp this, so I just use my hand when I do this and lay a bead across that chamfer, and then we're going to grind that flat and smooth. Now if you did what I did, you can see here there's a slight gap right there, just because I wasn't holding it tight enough. Not that that's a huge deal, but we can get that out if we use a clamp. Squeeze it tight and then lay a weld right there. As you can see, Brent is a surgeon with that flap disc, and that weld came out really nice and clean, and it's nice and tight. And then he hit it with a small flap disc wheel that was on a die grinder, and then finished it off with a DA to kind of blend it all together. Okay, so now we're gonna weld up the tracking knob. This essentially is a piece of plate steel that this bolt fits right up into it. I like to leave this bolt lower a little bit to fill this in, and then we grind it back smooth and flat. In order to make that happen, we're going to slide a 3/8 inch washer up on this bolt and the nut threaded up to kind of set our depth so that it makes it easy to weld that down into place. Spinning that gives you the space you need for that weld. We're going to go ahead and fill that in and then grind it back flat. All right, so now we've got our tracking arm all welded up and fabricated and our knob all ground down and fabricated. We're going to go ahead and set this into its resting place, and you're going to grab a 3/8 by 16, 2 3/4 inch long bolt and slide it through the hole just like that. Okay, rest this down like that. And then there's a nylock that comes with the kit. You're going to thread that on and tighten that down as well. Now with this, you kind of want it to you want it to be tight. It doesn't have to be super tight, but you don't want any side play, all right? So it should not move left to right at all, but it should swing fairly freely. All right, so we're going to take our tensioning spring. We're going to have it upside down like this, right? And we're going to place the hook through the slot. We're going to bring it up, right? Just like that. And then we're going to turn it counterclockwise and kind of nest it down under, and then the hook of the spring should go up through the hole. All right? So I'm going to do that one more time, kind of slow so you can see it. Hook it through the slot, lift it up, turn it around, jimmy it into the hole. Okay, so that gets your spring in the right position. And then we want to position the tensioning arm in such a way that you can slide the top of the spring down and into the tracking arm. That is a beautiful piece of engineering right there. I love that. That's an awesome update for this grinder. By the way, these springs are all American made, custom made, for house made in Nebraska by a company. We have these custom made now right here in the United States. Yes. So now we're going to take our spring plunger. This is a detent pin. This is a new feature of this Evolution grinder. And we're going to take one of these little thin 1/2 inch 13 nuts here, and we're going to just thread this on. And you might have to do this a couple different times just to kind of feel, to get the feel for how deep this thing needs to go. But I like to thread it on about halfway, okay, like that. And then we're going to thread it into this hole here. Now what this whole operation is doing, as you can see when I pull this tensioning arm down, there's a hole in the tracking arm, okay? This spring plunger, what it does is when it's in its open position, it will allow the tracking arm to move freely. But when you turn this knob right here, it locks into place and the spring plunger comes out and it locks this arm in the down position. That way you can change belts, or at the end of your grinding session, a big reason why people get belt wobble is because they leave their belts on their machines, and then over time the belt stretches in a weird way and then the belt wobbles. Well, this is going to solve that solution, and it's going to make it easier for you to change your belts. Now, you're going to grab a little bit of your Loctite 242. It's my preferred. You're going to put a little bit on the threads here because we don't want this coming out. And then we're going to thread that right into this hole. We're going to grab a 3/4 inch box end wrench and tighten that down. And what you want to make sure of is that when it's in its open position, that the spring plunger is not proud of the interior face of that plate, okay? Just lock that down, and you can see it's not sitting proud, because if it's sitting proud, those threads are sitting proud. That's the whole point of that nut, is that it stops that from going too deep, right? And then in its closed position, it actually pushes out and through, right? So we're going to go ahead and put it in the open position. We're going to pull down the tracking arm, and you can see it locks itself into place. Another great addition to this grinder. I love it. So now you're going to grab your secondary tracking knob, which looks like this, 2 flat 1/4 inch washers, look like this, and the 1/4 28 nylock nut, all right? And we're going to thread that through. Slide a washer down onto this bolt here, like this. And then we're going to thread it through this hole in the face of the tracking handle. Then another washer on the back side. And then we're going to thread this nylock nut onto that knob. The trick to this, what I like doing, this is a 7/16 inch outer diameter of this nut. I'll use a deep socket with an impact wrench or some sort of drill, and I will just hold the end of the knob and use that drill to seat that down. Now, you don't want it too tight. You want it still to be able to spin. This should be able to spin freely, but it should be snug, I'd say, is the right word. Then you can fine tune it with a wrench. That's about right. Next, we're going to take our Hinge joint, which looks like this. We're going to thread it on the back side of that knob. You want to kind of try to eyeball it and line it up with these holes here. Now we're going to take a 3/16 1 inch Allen bolt, put a little Loctite on it, or a lot of Loctite, whichever. And grab your tracking mechanism, set it down on top, and thread the bolt through the top and into the tracking arm. Again, you don't want to snug this down too much, but it does need to be snug. so it can still spin. You want it to be flat, but it still needs to be able to go back and forth. The Loctite will hold the bolt in, so you won't have to worry about that. And to finish off the secondary tracking, we're going to grab a 5/8 inch long button head that we provide in the kit. We're going to apply a little bit of Loctite to that as well, to drop works. And then you're going to want to align that Hinge joint by turning this knob with the hole in the end of the tracking mechanism. Just get it as close as you can. Take your bolt, slide it into place, and thread it in. Last but not least, you're going to want to take that fancy knob that you made and thread on the 3/8 inch nut to it. Slide it quite a ways up. And we're going to insert it into this hole here and thread it into the hole on the opposing side of the tracking arm until it comes through the face about a 1/4 inch or so is all you need. So now we're going to go ahead and mount the tracking wheel. So we're going to grab that, and we're going to grab our tracking bolt, slide a 1/2 inch washer over it and one of the wheel spacers. We're going to slide that through the forward hole. Apply a little bit of Loctite to those threads. Grab the last spacer, slide it over the bolt, and thread it into the tracking mechanism. Just want to snug that up lightly, and you want to make sure that the wheel can spin freely. It's not going to spin like a skateboard wheel, but it'll spin freely like that without any resistance. All right, so now we're going to move on to the Platen arm, and we do need to grab the spacer for this. This gets welded to this arm. The holes in this spacer are oversized, so this isn't a super precise operation. You just need to align it so that the holes are just basically concentric if you can, and then place a weld on the backside of the spacer. Make sure you clamp it down before you do this to ensure that it stays flat up against the arm. All right, so now we got our Platen arm all done. We're going to go ahead and slide it into the receiver here and grab one of our adjustable locking knobs here and thread it into that top threaded hole just to kind of hold it into place for now. And then we're going to grab our D plate, and we're going to grab a 3-inch long 3/8/16 bolt, slide a washer over it, and slide it through this hole right here on the D plate. And then this bolt gets slid into the forward hole in the arm. Grab another washer, slide it on the other side, and lock it down with a nylock. You want it snug, but it should still turn. Next, you're going to want to grab your carriage bolt and a clamping knob, a flat washer, and a split washer. Slide the carriage bolt through the slot and into the arm. The flat washer goes against the arm, the split washer goes up against the clamping handle. Next, we're going to grab our Platen bracket and our Platen face. I'm just going to lay them down on my work surface. It's a little bit easier to do this. Lay it down so the tabs are facing up like this. Grab a couple of flat washers, lay them down. You got some 1/4 bolts that you can thread into the face itself. Alignment doesn't matter so much with this just yet. We're going to adjust that later once the grinder is all assembled. And then we're going to align that Platen bracket assembly. Grab some 1/4 bolts with the washer and thread them in. Next, we're going to bolt up the wheels to the Platen. You have a 6-inch rubber contact wheel and a 3-inch rubber contact wheel. We already pre-insert all of the hardware for you. All you have to do is untwist this nylock on the end, because that goes on the other side of the D plate. Thread these through the holes into the D plate and lock that nylock down into place. Use a 7/8 inch socket. Snug it down. Put the nylock on the other side. We're going to do the same thing with a 6-inch contact wheel on the bottom. Don't forget the nylock on the other side. While we're at it, we're going to put in the locking bolt for the grinder head. This is a 1-inch by 3/8 16 bolt. Don't need that tight, just snug it up. Okay, so now we're going to weld together the work rest arm. Orientation matters in this case. You can't flip this part over. The arm itself is just the tube with no holes in it. You're going to set that down on your work surface there, and you're going to want the, if you're facing the grinder, it's to your left and this is pointing down. Now don't just reference this video, look at the drawings in the instructions before you put this together, okay? Because orientation does matter. Now what you're going to do is you're going to set this on about 1/8 of an inch back from this hole right here, this plug hole, and the face of this arm. You're just going to put about 1/8 of an inch worth of distance between those two, clamp it down to your work surface, and plug weld those holes. Okay, so you're going to want to grab all your parts for your work rest assembly. One real quick comment about these arms. Sometimes they get a little tight after you've welded everything in. You can use a flap disc and you can take down the high spots if your arm is tight and make it fit nice and smooth. You're going to want to grab all your other parts, which are these clamping handles and carriage bolts set up, along with a machine screw and clamping handle. This is for the work rest plate itself. You got a work rest arm handle and a couple of set screws that we're going to go ahead and put into this bracket right here. And that's really just for alignment, just to make sure that the work rest is exactly 90 degrees against the platen. All right, so you take your platen arm, push it all the way back, lock it into place to just kind of get it out of the way for now. Take the work rest arm that we just welded up a few minutes ago, slide it into place, turn the entire grinder head on its side, and then mount your work rest knob on the lower hole there in the receiver. Okay. This will slide in and out, just pull it out just a little ways. Lock that into place. We're going to take this hardware, which is the carriage bolt, flat washer and split washer, and the clamping handle, along with the bracket and the set screws. Now the set screws go up underneath the work rest. So we're going to align these two slots here. Slide the carriage bolt through underneath. Get a flat washer, a split washer, and the clamping handle. Lock that down nice and tight. Okay. We're going to take this hardware setup, which is the machine screw, flat washer, split washer, and a clamping handle, and a 7/32 Allen wrench. And grab our work rest plate here and set it up on the bracket and align that hole with the slot there. Take your machine screw, drop it down into place, add your flat washer and your split washer to that screw or bolt, and then add the clamping handle down underneath. Just get it loosely tightened down because you got to kind of align it with the platen just to hold it into place so it won't fall off. And now you can loosen your platen, pull it out a little bit. Loosen that up and then slide this over so it aligns with the platen itself. So now we're going to grab our square, set it up to our platen here. Now again, you may need to adjust this later, but for now I'm just going to show you what those set screws do, and you can see this is pretty close, but you do have a little bit of gap there down towards the bottom, which means that the far side needs to drop down a little bit. So you grab your square and a 3/16 inch Allen and just go up, adjust with your set screws and bring that up into where it needs to be. May have to loosen the bolt just slightly. Just give you some room. As you can see, I can bring that into square really easily and then lock this all back down. All right, now we got a perfectly squared up work rest. We're gonna move on to mounting the motor. All right, well, now we're gonna grab our motor, and if you're confused about which motor and VFD to purchase for this build, we have a resources page that's filled with links to Amazon and convenient places to purchase motors and VFDs, and I also have a wiring video that shows you how easy it is to wire up one of these motors. So make sure you check that out. I'll put a link down in the description for that. The easiest way to mount this motor that I've found is mount it horizontally. Leave the motor down on the work surface. You're going to want to tilt the grinder down, up and over the motor itself while it's horizontally laid out, and then use a clamp and clamp down the motor's base plate to the work surface. That way this isn't moving around on you. You're going to want to have at the ready your 7/32 Allen wrench and your button head bolts that are going to go up into the motor here. And this can get a little fiddly, so you know these motors are not light, so just keep that in mind. I set a bolt up top, and if you have a friend, you got somebody that can help you with this, it's even better, right? Also, I'm going to leave this cap on the shaft of the motor, okay? There's a little plastic cap that comes with this motor when you purchase it. I'm going to leave that on because I don't want to ding up the shaft, okay? So I'm going to go ahead and get my hand up underneath the motor itself and align the holes. And if I can just finagle one screw into there, one bolt into there, which I'm getting pretty good at it now. I've built so many of these things. Takes the weight off, and then I'm going to do the opposing side here. Tighten that down and put the other two bolts in and snug those up. A couple of these motors we found, these threads are not deep enough, and we've just had to run a 3/8/16 tap through them just to get that hole just deep enough for these bolts. In this particular motor, it was only one of the holes was bad. So just keep that in mind. You know, it's a good idea to have a 3/16 tap around for other projects as well. So not a big deal, it's aluminum, it's easy. And now we're gonna put on the drive wheel. Just keep in mind that this is a cap, okay, and it slides off, and there is a key here in the keyway, and this cap protects the shaft from getting dinged up, and it keeps the key in the keyway so you don't lose that, all right? So we're going to take the drive wheel and slide it over the shaft, all the while eyeballing that keyway just to make sure that everything's in alignment. If the key keeps sliding out, you can slide this over without the key in it and then get it aligned enough to slide the key down into the shaft itself. The face of the inner part of the wheel should be flush with the end of the shaft, and then you're going to use a long 1/8 inch Allen key and tighten down the set screw. All right, so now we're gonna throw a belt on to this thing. You get a chance to use your detent pin, so go ahead and pull the arm down, lock the tracking arm into place, throw a belt over top here, kind of loosely, loosen this arm up, pull it out, give yourself a little bit of slack. You don't need it super tight because this is gonna come back up once we release that detent pin. And we get a chance to see how it's tracking so far. Looks pretty good, not terrible, not perfect either. We're going to just adjust the tracking slightly just to kind of bring everything in. And also this is, the Platen bracket itself is pushing up against the back of the belt. So we're going to loosen these screws just slightly and kind of let the belt push back the Platen. That's the step that you don't want to forget. You don't want it pushing up against the back of the belt. You want it to be just behind it. And, you know, like think about it like maybe a 32nd of an inch or so, or a millimeter or something behind it, right? And tighten that down. And then much quieter, belt is running a lot straighter. Although we have some distance now between the belt and this left side of the platen, so we're gonna use our secondary tracking and just bring that belt over. Looks pretty good. For right out of the box, it looks pretty good. Now, if you've got your platen is cockeyed or your belt travels diagonally across the face of your platen, you can adjust using those screws in the back. You can adjust the wiggle. You got a lot of wiggle room there to adjust the face of this platen. This is a nice feature versus the Revolution, where that was all static and you didn't have the ability to change, you know, where that sat. So I can just go back here and loosen this up and then bump this over a little bit. Tighten it back down. Just like that. One of the best features of the Evolution is that it can run both a 2-inch and a 3-inch wide belt. The tracking wheel and the drive wheel are both set up for a 3-inch wide belt. All you have to do is change the attachment in the front, meaning like the platen, you can swap that out for 2-inch platen or 3-inch platen. And we now have big, massive contact wheels, the 3-inch wide and the 2-inch wide. So that is just such a cool feature. That's why we called it the Evolution, actually, is because it not only evolved from being the Revolution, but it evolves with you, the maker, the guy who's using it every single day to do the work that you do. All right, guys, so that's the Evolution build. Now, if you are interested in putting one of these machines to work in your workshop, make sure you go out to our website at housemade.us and see all of the kits that we have available for this machine. And you can also purchase fully built powder coated machines right for your workshop, so you don't actually have to build it if you don't want to. Also, we have so many accessories now for this machine, and all of those accessories are reverse compatible with our other machines. So you don't have to think about it. If you have a Revolution in your workshop, you want to add an Evolution, everything will switch back and forth. Thanks again, guys, for watching. I truly appreciate all the love and support throughout the years. I hope to see you in the next video. My name is Brian House, and this has been Housemade.